Hello, we're the Soda Buddy team from Alexandria Technical and Community College. We are all second-year students. This is our soda dispensing machine. It uses pneumatic actuation and electronic control to dispense you a soda. My name's Daniel Chumley. I'm from Annandale, Minnesota.
I'm Patrick Soaring. I'm from Detroit Lakes, Minnesota.
I'm Zach Molden from Benson, Minnesota.
And I'm Tony Orm.
So I did the mechanical assembly and design. Our first task was everyone was to brainstorm and draw a hand sketch or a napkin sketch, and they're quite different from what we came up with. After that, we had an 8-week design period. Some of the major issues we had in designing was how we wanted to move the can from this end of the trough to this end. We had an idea for an air motor that was going to have a reel and pick this up. We also thought about using a cylinder down here, but it took up so much space we decided to go with this, which ended up being our best option. Another challenge we had was this ramp. We had it spec'd for channel and ended up making this out of 80/20 and Lexan. Worked pretty good because it's adjustable, it's good material to work with, and you can modify it as needed. Here's our final design. So you can see a few different views. It's turned out well. It's like we had planned. Another problem we had was this cylinder here was actuating up and down, and it would lift the can or pinch it, and we changed the angle, and now it splits the can nicely. And those were the main things.
I was in charge of all of the pneumatics on the machine. We used air cylinders for our actuation. We have 3 cylinders that hold the front gates, and then we have 3 cylinders that hold the gates to hold the pop in the back. We also have cylinder to slide the cans across the trough. For each of the cylinders, we did use flow controls. We have the flow control here, and we have flow controls on the sides here. That controls the speed of the gates when they rise up. This is the pneumatic schematic. It basically shows how everything will work in the circuit.
Okay, I did the electrical and the design of the electrical panel right here, as you can see, and I wired up all the push buttons and the reed switches. You got right here the electrical schematic. It just shows where on the PLC every component's supposed to go to. And we made the electrical panel out of 80/20. It's a 20x20 piece. Okay, over here we have the photo eye. It's a retroreflective one, and it's placed here so then it can see this retroreflective circle right here. So what that does is when a pop can gets in front of it, it tells the PLC that there's a pop can there, and then it runs the cylinder. The cylinder up here and makes it move. And over here we have our reed switches, which is one on each cylinder, 3 that are on the bottom and the back ones, and then there's 3 that are on the top, on the front ones. And what it does, it tells you that when the cylinder is either on it all the way down or all the way on top.
I was in charge of the PLC programming and the electrical schematic. We used Micrologic's 1000 analog for the programming, and we used RS Logic's 500 on the computer. So the process is, when the Coke button is pressed, this cylinder will go down for a set amount of time, and then once that timer is done, it will trigger the back cylinder to go down, and as soon as it hits this reed switch down here, that will trigger this to come back up, and then after that, the photo eye would be blocked with a can, and that will trigger this cylinder to slide to deliver the pop can. So this is our PLC code. For each process, I use the push button to latch a bit, which then triggered that timer that I was talking about earlier. Then after that, it has the done bit unlatching that bit, and then after that, it triggers another timer for that back cylinder I was talking about. And then I have bits for the front one and the rear one to say, okay, this cylinder I am done, so now the photo eye can move to make sure the pop can is in the trough, so it's not or delivering nothing. For the randomizer process, I used a counter right over here, which on the rung, it needs the random push button plus an accumulated count from the counter. And then I used the Coke, the Mountain Dew, and the Dr. Pepper push buttons to count on the counter. Then I used a grater then to reset itself. So if it gets to accumulated count over 2, it will reset and then it'll be all random again. Now let's watch it run.
Thank you very much.
Now let's try random.
And that's the soda buddy.